Welcome to the sequel of Origin Symmetry. We'll call this part 2. Now we're going to test these. If you have not watched part 1, go back and watch it. And then try these problems as extra practice. So pause it now and work them out. I'm going to go right ahead. I'm going to use this bottom definition again. And I'm going to do f of negative x. And then I like to make 2 columns out of this. Because I'm going to come over here and do negative f of x, because this definition says a function that is symmetric to the origin is symmetric to the origin if and only if these 2 things are equal to each other. All right, so let me show you this. We're going to do f of negative x, which means I need to plug in negative x everywhere I see an x. So check this out. I think you can see what I'm doing there. All right, I'm putting parentheses where the x's are, and I'm going to plug in negative x right inside there. I could have done that with a different color and been a little bit more dramatic with it probably. Let's do that. Here's negative x. All right, now we're going to work some algebra kung fu on this. This is negative 7, make that a little bit lighter, times negative x to the 5th. That's negative x times negative x times negative x 5 times. And that's going to be negative x to the 5th. Okay, if that was to the 4th, that would turn positive just now. But it's negative x to the 5th. Plus 8 times negative x, so that's going to be minus 8x right there. Now, this is going to turn it positive. So this is 7x to the 5th, because I have a negative times a negative, minus 8x. Okay, I'll put a circle around that, or a box around that, because I have to see if this is equal to the other side. That's negative, or f of negative x. Now, let me show you how to do negative f of x. It's basically just negative 1 times this function. This is the easy part. All right, negative 1 times that. So we need to distribute this. Distribute. So this is 7 positive x to the 5th minus 8x. And we can see that negative f of x, which is here, equals this. So these 2 things are equal. Therefore, the answer of does this have origin symmetry is a big old yes. A big old yes. So let's review those steps. You plug in negative x into the function, evaluate it, figure out what you have, and then you turn around and do negative f of x, which is multiplying it by 1. I'm going to set this up for you, and I want you to pause it and knock this thing out of the park. So f of negative x, do that in a column, negative f of x, and do that in a column. I'll be right back. Try it. All right, let's do this. F of negative x equals 2 times negative x plus 1. That would equal negative 2x plus 1. Final answer. Let's try the other side. This would be, do this in yellow, negative f of x would be negative 1 times 2x plus 1. Well, if I distribute through here, that's going to be negative 2x minus 1. And that is not equal. These 2 things are not equal. Therefore, the answer is no. Now, just real quick, let's look at why that is based on the first part of the definition. If I draw a nice, quick little graph and use f of x equals 2x plus 1, which is the one we just did, and I graph this really fast, this would be something you should be highly skilled at this point, up 2 over 1. That's what that looks like. Draw a line there. Okay, this is the graph of 2x plus 1, and it is not symmetric to the origin. Here's why. The first part of the definition says point AB, if AB is there, then negative A, negative B is also there. That's what that boils down to. Okay, let's take a point right here. That point right there is on that graph. It is 0, 1. If this thing has origin symmetry, then the flip-flop version of that, the negative version of that, -0, -1, has to also be there, which would be 0.0, -1, because there's no such thing as -0. But negative or 0, -1 would be here. Is that on the point? No. No, it's not. If we look at a third and even better example of origin symmetry, this will really nail it for you, I think. If I do my best and make a letter S, here we go. Not too bad. You can see it's almost like a dollar sign. All right, watch this. If I have this point here, is the negative version of that on this? Yes, it is. If I have this point, is the negative version of that on there? Yes, it would be right here. How about that point? Well, it's right here. And this point on the corner would be right there. This thing has origin symmetry. It has origin symmetry. A circle, if I were to make a circle on this graph, say that, it would have origin symmetry. This point, 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 and so on. That has origin symmetry. But if we go back to this, it does not, because you can see that this point is not reflected down there like that. All right, have a good one.